Hello everyone, I'm Sadia Ahmmed and I'm gonna present MIMIC, which stands for Multimodal Islamophobic Meme Identification and Classification. And this paper is accepted in Muslims in Machine Learning workshop, which is co-located with NeurIPS' 2024. Throughout this presentation, I'll be discussing about the motivation, the research gap, the approach we used, our methodology, our analysis and key findings, any limitations that we have, and how do we want to it in the future. And finally, we'll end it with the concluding remarks. Well, we are motivated by the social media itself. Well, we understand from our research that social medias can effectively identify any textual form of hate speech, including textual Islamophobia. But the problem starts with the rise of memes, which uses humor to spread any message. And it has become a popular form of communication. But with the rise of memes, we see that it is also being used as a form of online hate speech and also for spreading Islamophobic content. We have noticed that there is a significant gap in tools for detecting multimodal Islamophobic content, particularly in memes, which is a blend of text and images. Moreover, since memes uses humor, there is also a lot of contextual and cultural understanding required. And we see that there is a limited consideration of contextual and cultural nonsense in Islamophobic content or Islamophobia identification. And we also wanted to stress the societal impact of addressing Islamophobia on digital platforms. To understand why is this existing, we actually dive deep into research arena. And we found that the existing works only detect Islamophobia from textual hate speech. And from this subset, only a few work detect humor-based Islamophobic sentiments. Moreover, there is no such work that tries to detect Islamophobia through memes, which is a combination of image, text, humor, and of course, hate speech. As a result, contextual Islamophobia remains undetected. Now, with an effort to tackle Islamophobia that is delegated through a multimodal format like meme, we propose the first ever dataset on Islamophobic and non-Islamophobic memes detection, which is being collected from multiple social media platforms. We then extract the text of the memes from the images using OCR to understand the message of the meme. We then train a visual language transformer by giving it a text extracted from OCR and the meme's image as well to find out Islamophobic elements in it and classify them as hateful versus non-hateful. So we have come up with Mimic and we plan to contribute in two areas. Firstly, we have proposed the first ever Islamophobic memes dataset, which will open a big horizon of research. Secondly, we have contributed in the field of multimodal reasoning and classification.
So one of our contributions is the very first Islamophobic memes dataset. We collect 953 memes from four media platforms: Reddit, Twitter, 9gag, and Google image search. Out of these 953 memes, 545 are not hateful and 408 are hateful. So let's go through our brief methodology. We take an input image meme and we do an initial data processing. We use OCR to extract the text from the images, and we resize the images to the same dimensions so that we can easily do a batch-wise training. Then we move on to the embedding, encoding, and projection phase, where the input image is divided into meme batches and then apply the positional encoding. For the text, they are tokenized and a word embedding followed by a positional encoding is applied. Finally, these image batches and these texts are passed into the vision and language transformer with the ViLT base 32 backbone, and their nuances are learned. Their multimodal interactions, the text and the image, how they are interacting with each other, truth in the image are learned and is passed to the classifier head, which is a MLP, sequential MLP, with that outputs or that has one neuron in its output layer that outputs anything between 0 to 1 using a sigmoid activation function. Now, let's move on to our analysis and key findings. Before we start, we would like to mention that each of these models were run 5 times and their median scores are recorded. So we can see that from all these scores, the ViLT base 32 performs the best in terms of F1 score and even in terms of F1 score and in terms of the loss. The ViLT performs the best among visual BERT or clip. However, our data set it's very small. It's very small. Initially, it's very small. So what we do is that we try to apply an augmentation technique. We apply the random rotation augmentation technique and increase the data set and increase the training set size. And we can see that as the data increases, the scores get better. And we've actually crossed the 70% mark. This shows that the model will get better and better, and the methodologies will get better and better as we expand our data set, as we introduce more data into the data set. And we can see that when k is 5, the F1 weighted score is 0.716. It has crossed the 70% mark. And when we increase it to k fold 10, we can see that it's already increasing by almost 2%. Well, to start off, it has a very small data set size. And in the future, we plan to expand this more. The labels are binary. There's either hateful or non-hateful. However, Islamophobic just cannot be classified using hateful and non-hateful. If we want to do a more fine-grained classification, we perform a k-fold cross-validation on that demonstrates the model's promising performance on this dataset. And we've only analyzed this methodology using just 3 visual language models. However, we aim to incorporate more visual language models for broader insight. And currently, our dataset has only images. However, we know that memes are also videos, memes are also GIFs. So we aim to introduce more labels such as overhit, coverhit, and misinformation. So we plan to incorporate more data modality. In conclusion, this is the first attempt that has been made to combat Islamophobia through memes, and we've also created the very first Islamophobic memes dataset. And we show multimodal VLMs show promising performance in classifying the data, and when the dataset size increases, we can actually get more better scores. Our work is public. We have released the code and dataset to our GitHub repository for easy reproducibility, and we also have our methodology submitted on ArcSci for easy to view access. Thank you, and that is all.